Hello everyone, this is Dan Gert from Flexagon. Welcome to our webinar series. Today it's all about cloud, containers, and CI/CD. I'm here with Eugene Fedorenko, a colleague of mine who is a senior architect and heads up a lot of the development in and around microservices and containerization and such, and we're happy to be here to share a lot about what the problem space is and how we solve it within our software FlexDeploy. So we've got, I'm sure, a real good audience that has a mixed bag of understanding of our technology. So in addition to walking through an overview in the presentation, we'll also fire up about a 20-25 minute demo and bring all of this stuff to life. A few things for housekeeping. One, if you can put your questions into the Q&A section, then we will take questions at the end. So please post whatever questions you might have. We appreciate that. The other thing is that we have a webinar series, and there's any number of webinars covering a bunch of different topics from base DevOps, as well as focused on specific technologies from eBusiness Suite to Salesforce and MuleSoft, and a lot of other good things out there. So when you see the communication come through, the follow-up, look for some information around those as well. And so we are in our last webinar, and this really tails back to and connects well with one of the webinars we did a couple months ago, where Eugene took us all through the containers, serverless, and functions, a broad overview that really wasn't connected to FlexDeploy itself. But now we're bringing it to life, turning that corner and really connecting it into the details. And so with that said, there are challenges that we all face, whether it is using, call it legacy technology or traditional technology and processes, as well as certainly challenges we face using newer architectures, microservices architectures, containerization, serverless, and what have you. And they cut across cost, speed, and quality. So some of the same challenges we have, they may look a little different, they may manifest a little different depending on the architecture and the technology, but at the end of the day, there's still a challenge that we need to address because they get in the way of basically being able to deliver at the speed, quality, and cost that we all need to. And so to get after those things and really address some of those challenges, these are just some of the drivers for change, the things that we've been focused on both as technology providers, as systems integrators, certainly as an end customer applying and adopting technology, trying to improve where they're at today, as well as adopt newer technologies. So it's anywhere from process orientation and people orientation around Agile and Lean. It's adopting full CI/CD, the broader DevOps, as well as things like release automation. So anchored at the bottom of this thing really is a lot of automation. And so certainly we focus on that here at Flexagon and within FlexDeploy. But eventually all that really matters is that we're able to accelerate the delivery of different aspects of technology, of software, improve the quality, and then really not only reduce costs, but deal with some of the risks of making changes and getting that business value that we need. And so to that end, we've got FlexDeploy, which is our DevOps platform. So it's really a comprehensive platform that does build, deploy, and release automation. And so a lot of out-of-the-box capability that you may already be familiar with, or you might not. But the key is that a lot of right out-of-the-box content, as well as being open and extensible. All right, very important to balance both of them. And these third-party plugins, some of which we'll talk about today, around Docker, Kubernetes, and a few others, a lot of stuff that's right out of the box that you'll be able to take advantage of, and supporting both traditional and continuous delivery. Certainly, we love CD. We want to go faster, right? We want to iterate and deliver faster and faster. But the reality is there's enterprises out there, many of them that still have some traditional processes and approaches. And so we want to help everybody, but generally speaking, tend to move more toward the continuous delivery. And with that said, this slide right here talks about that reality. It says, okay, maybe we have a lot of traditional databases and middleware and applications that we're leveraging and lining up toward basically to the left-hand side of these continua. on-premise, large monolithic systems, and all of that. And we need help to help those as well, and certainly we do. But in this particular webinar, we're focused more along the right-hand side. So how does this work? How can we decompose our applications into microservices? How can we deliver more consistently, more rapidly, more continuously, right? And how do we adopt things like containerization or serverless with functions to be able to do those things more effectively? So when we step back and we look at Flex Deploy and we talk about how we solve some of these challenges in and around containers and cloud and microservices and such, we'll always talk about three main pillars of the platform. That they work with the newer architectures and technologies and with everything else, and that's build, deploy, and release. So how are we going to build and package up changes, store them into an artifact repository, then deploy those changes to some type of runtime, whether it's running on-prem or in the cloud, and regardless of whether it's infrastructure, middleware, database, applications, all of that needs to be deployed somewhere, and then managing releases. So 1, 10, hundreds, thousands of changes that we want to group together, manage and orchestrate together across some type of pipeline to be able to deliver as effectively as we can. And so we'll talk and bring that to life mainly in the context of the demonstration, but across the entire pipeline, there's role-based security, the ability to orchestrate tests of all different sorts, and then put the governance and controls that make sense in place, as well as having visibility via dashboards and reports. So let's get rolling into some of the more of the detail in terms of what we're going to talk about and demonstrate today. This Winter Olympics 2018 application, well, it's something we built, I guess, coming up on a year ago. And the key is it's going to show off the ability to work in the context of microservices. In our particular case, this dashboard microservice that's part of a much larger and more complex overall solution. And so we're going to hone in on that microservice and break that thing down. And really to oversimplify things, this is about as simple as it gets to describe a development life cycle. And whether you're using Git, Subversion, Perforce, pick your favorite flavor of source control, we're going to pull source out of the source control system, out of GitHub. We're going to perform that build operation, right? So in this case, we're talking about how we're going to handle this dashboard, this microservice. So we're going to build that, and then we need to deploy that, right? We've got to push that across development, test, and ultimately into production. So that's the problem space that we're dealing with that we're really going to decompose here. And so I'll turn it over now to Eugene, because we're going to tag team on this, and he's going to drill into some more of the details as far as how the challenges and some of how we solution this.
Okay, Dan, thank you. So the use case that you have just described looks very familiar, and it seems to be pretty simple, but there are some challenges to think about. There are some things to be considered. So even though the microservice is pretty simple, it is a multi-layered solution consisting of a database, middleware, and front end. So technically, the database layer is a bunch of tables in an Oracle database schema. The middleware layer is implemented with ADF business components, exposing REST services, and the UI is an Oracle JET application. So obviously, in order to get it working, we need a platform for every single layer. So for example, Oracle Database XE Edition for the database layer, WebLogic or Tomcat with ADF runtime for the middleware layer, and Nginx Web Server for the front end. So our microservice and the entire application, the entire Olympics solution depends on this stuff. And this stuff, it should be properly installed and configured. It means that actually the entire solution consists of two parts, the implementation and the environment. Normally, the software development lifecycle involves more than one environment. In our solution, there are three, dev, test, and prod. So there's one implementation and many environments, which actually means there are many variations of our solution. And usually what works fine on dev fails on prod, just because of different libraries, drivers, JVMs, or phases of the move. At the scale of the entire application, this issue is getting bigger, targeting to become a nightmare that we're all familiar with. So, the idea is to put everything together, application and environment dependencies into one package, and deliver it from dev to prod as a unit, as a container. Actually, this idea is as old as the computer science itself. The only thing is that it has been hard to implement it technically. There has been always a problem, a huge overhead. Some people have done that by the means of virtual machines. It works, but not good enough to become an industrial standard, to become a way to go for everyone. Virtual machines are typically huge. Packaging, delivering, and starting a virtual machine has been always a slow process. But fortunately, some smart guys decided to leverage Linux kernel features such as namespacing and control groups to create an isolation level on top of the host operating system rather than on top of the hardware. The idea on one hand and the level of the performance of modern hardware on the other hand brought to the world the notion of containers as we know it today. These containers are significantly more lightweight than virtual machines. You can run thousands of them on a machine and it won't even blink. Actually, there have been a few implementations of this concept, but today Docker is de facto an industrial standard, and whenever we think of containers, we actually think of Docker. So, if we look at our microservice and at what it needs, we will want to package every single layer into a container, containing both an application and a platform with this application. And the platform in each container is going to have all necessary libraries. It's going to be pre-configured and tuned to run this specific application. And what is very important is that every container, every layer is going to be shipped across environments as a unit. And I'd like to draw your attention to the fact that our microservice was a microservice before containerization. What I mean, just before containers and microservices work well together, they're pretty often sold together by bloggers, conference speakers, as if they were the same thing, as if when it comes to containers, it's all about microservices, and the other way around. Well, it's not how it works. Actually, microservices is a different level of abstraction. This is just a pattern decomposing your monolithic application vertically into loosely coupled subsystems. That's it. Just to quickly say it again, we can use containers with a monolithic application, and we can go with microservices without any containers at all. But today we are going with microservices and containers, and our microservice is a composition of 3 Docker containers with the following content. So our front end is based on Alpine Linux with Nginx web server and an Oracle Jet application. The middleware layer is based on Tomcat application server with pre-installed ADF libraries and ADF business components application exposing the REST API. And the UI, for the UI, and the database container comes with Oracle Database XE Edition, and it contains all necessary tables for the microservice. So, having our microservice decomposed into containers, the next step is to build images for those containers. It's a good practice to build images based on Docker files, as it is a straightforward, simple process which can be easily automated. So, for every single layer, we're going to create a Docker file, and we're going to use it to build an image with Docker build command. And this will create an image in the local Docker repository. Local meaning that it is on the same very computer, on the same machine where we invoke the build command. And in order to make the image available for everyone, we're going to publish it to the cloud registry. So Dan, what do you think about that?
Yeah, absolutely. I think you covered some of the fundamentals that are very important to supporting, the development life cycle and applying, call it containerization in the context of microservices, as you mentioned. And so we're going to have that. We're going to create that build, execute that build. We're going to have that image created. We're going to get that out into the Docker Hub, in our case, or whatever repository that you might be interested in. And then we need to deal with the challenges of deployment, right? And so there are options that we could take, for example, to take that image, that Docker image, and deploy that into a Docker runtime. And that might work in some simplistic cases. It certainly does work in some more simplistic cases. But the reality is when you start to build, design, and implement systems that heavily use containers, that's really not good enough, right? So we need to be able to manage that complexity and then deploy across our different environments. And so we're going to break this down a little bit to talk about what that means. And so specifically, what we're applying here is the use of Kubernetes. And so we're going to, via I'll call it the magic of Flex Deploy, we're going to be able to take those images that then were stored in the repository and then automate the process of deploying them across different Kubernetes runtimes. And so in this particular case, we're showing Google, Amazon, and the Oracle Kubernetes engine. In the environment, or in the demo environment, as a matter of fact, we've recently made some changes. So we support any Kubernetes runtime, but what you'll see in the demo is that we're actually deploying to an on-prem, right, in the Flexagon data center, Kubernetes cluster there, as well as then in test onto Amazon and then prod onto the Oracle Kubernetes engine. So, flip that back over, and Eugene, as the technical expert here, is going to help break this down and really start grounding you in a little bit more about, so what does this mean to be able to implement the build and deploy workflows in the context of Flex Deploy?
Yeah, so as you guys know, all activities in Flex Deploy are performed by the means of workflows. And a workflow is a composition of steps where each step is an invocation of a plugin operation or another workflow. So if we look at the workflow building the front end of our microservice, we'll see that at first it fetches the source code from GitHub and builds an Oracle Jet application. And at the next step, build and push Docker image is putting everything into a container and pushing it to the repository. So it uses Flex Deploy Docker plugin, and basically it creates a Docker image with a name provided by a project property and with a tag corresponding to the project build version. And the next step, prepare deployment profile, is to create a YAML file referring to the freshly built Docker image. This step takes a template of a YAML file for this project and substitutes the reference to the Docker image with the exact image name. And the result YAML file is going to be saved as an artifact to the artifact repository. There are similar workflows to build middleware and database layers, and each workflow obviously is assigned to a correspondent project so that the project knows how to build itself. In order to deploy a container to a Kubernetes cluster, Flex Deploy uses a deploy workflow. And this workflow consumes a YAML file produced by the build workflow as an artifact. And the deploy workflow contains a single step invoking Flex Deploy Kubernetes plugin that applies a YAML file to a Kubernetes cluster.
So hopefully that gives you a sense, whether you are familiar with Flex Deploy or not, at least some of the foundational aspects of how we're going to support the build deploy process. And so in addition to walking through call it that foundational aspect in the demo here in a couple minutes, we're also going to apply some other capabilities, ultimately what we call release and pipeline features, which will not only allow us to streamline the process of building and deploying changes across environments, but it allows us to put some controls and governance around that, just allow us to more effectively manage the overall delivery life cycle. And so the last slide here before we go to demo, this is really it's a screenshot of our release pipeline. And so we're actually going to go and look at this one specifically and bring this to life. But what you see here is just a bird's eye view into basically a release that is getting propagated across development, QA, and production. And as I mentioned a little earlier, Similar but not the same to the slide that I showed. This is being deployed to the Kubernetes cluster in the Flexagon data center. That's the development. QA is in Amazon, and production is in the Oracle Kubernetes engine. And so with that said, we're going to flip over and go to demo. And so basically trying to walk a fine line for those of you who this is your first introduction to Flex Deploy, and those of you that might know it and possibly even know it really well. And so I'm going to give you about a 20-minute overview here and bring all of this to life. So here we are. I've signed in as myself basically as a super user and as an administrator. So rather than jumping in and out of different roles, I'll just stay within the specific admin role that I'm in. And in a nutshell, there's a few things we won't focus on, but the role-based security model that allows you to slice and dice or segregate all the responsibilities, that's what would be down here. So just think that that's already set up. And then the topology allows us to basically configure Flex Deploy to talk with all of the different tools, technologies, runtimes, of course, Docker and Kubernetes and all sorts of stuff. And so if I go ahead and just show you briefly the topology setup for Kubernetes, although we have 4 set up, we're actually using 3. And so in essence, what we have is we need to configure Flex Deploy for each of the environments that we're going to use or talk with Kubernetes, and then configure the information associated with that so it can ultimately talk to the appropriate runtime, if you will. Okay, so we've set all that up. We've gone off and done things like setting it up for, in this case, using Git and GitHub specifically. But the general concept is to be able to configure this to whatever the tools and technologies are and make that a very fast and straightforward process. Now, I'll mention this in case anybody's curious that yeah, we're using the UI here to drive through basically everything, but we have a very robust set of REST APIs. So if you want to drive Flex Deploy administratively or from an execution or runtime perspective, almost all of the system is exposed via REST APIs. So here we are. We are looking at a few different projects. We talked about the Olympics microservice, and Eugene really broke that down and talked about the front end, the back end, and the database. And so here's what we have. And each one of these projects, so this is a Flex Deploy project, has a few things done to it so it knows what it's all about. So in this particular case, we have, I'll take the Java front end or the Jet front end, and if we come up here and look at the configuration, you'll see that not only have we configured Flex Deploy to talk with Git and specifically to GitHub, that we have, oops, I'm on the wrong guy here. Sorry about that. I'm now on the Jet front end, but in this particular case, we are still pointing to Git, but we have the build and the deploy workflows that we talked about earlier. Now, if you happen to notice the details, these workflows aren't exactly the same. We've made some modifications over the last few months, so our slides and the demo are a little bit out of sync, but the spirit is still there. So in essence, what we need to do is configure Flex Deploy so it knows what workflow to execute whenever a build and deploy are requested, whether that's from the UI like this, via CI, snapshot of a release, via REST interface, what have you. Okay, and so let's go up and look at those workflows. Some of this should look fairly familiar. If I open up the folder here for our build and deploy workflows in the container folder, you'll see a few of these things that look familiar. And so I'm just going to show you a couple of the examples. So we're in the editor. I'll bounce over here, and you'll get a view of basically a few things. So we've got our canvas in the middle, and this is really where, when we created this workflow, this one-time workflow that's reusable, we came over here and dragged and dropped the workflow operations and or plugin operations onto the canvas. So So basically refreshing some of what you saw earlier. We went ahead and did an export to pull the source, out of our source control system. We did a build of the artifact that's ultimately going to get built into or included in the Docker image. And then if I just bring up the Docker plugin here, you'll see that there's any number of operations on there. So clearly we're talking about a few of those, such as building a Docker image, such as pushing something out to a repository and that sort of thing. But just know that there are other operations that as you get into containers and want to manage this both at a base Docker level as well as within Kubernetes, that there are other operations at your disposal. Okay, so but what we did is we drag and drop those, right? We built the image, we pushed the image, and then we prepare that deployment profile. Okay, so this is the core of the workflow that we're going to use, repeatedly, if you will. And so we save that guy away and we're good to go. Now, if we come back and look at, maybe go down to the deploy to Kubernetes, this is that simple workflow that Eugene talked about a few minutes ago. And so we could go ahead and deploy that guy. If I bring up the Kubernetes, plugin, you'll see it has a number of different things underneath there, okay? So those operations are there. We just happen to be using just one of those, and oops, I accidentally moved off there. What you'll see is that we have some other information that you might need to provide in terms of anywhere from the context, so contextual information that you need to be able to deploy to Kubernetes, as well as this deployment template. So there's some implementation details that basically get done one time, and we're good to go. So again, similar to what I showed you before with Docker, we have something similar as it relates to the ability to perform other operations on the Kubernetes plugin and on the Kubernetes cluster. So once we have those created and configured, tied to our 3 different components and what they're called Flex Deploy projects, so that make up our microservice, then we're good to go. Other than there's a few other things we might have to configure up front, including some properties associated with this. So Eugene referenced the YAML file, so there's that deployment template. And so, excuse me, we needed to declare what that is or describe that, as well as the Docker image. So we put that information in. And so there's a few of those sorts of things that are important that we do in a one-time administrative shot. And then, if we want, we can do things like continuous integration. So in this particular case, we're going to kick off a build, if anything is checked into the source control system, and then automatically drive the process, the CI process that'll perform a build and then a subsequent deployment. Okay, so we can do other things that we don't have time to talk about and certainly aren't a focus of ours today, anywhere from driving automated tests associated with the build deploy life cycle, integrating with Jira, ServiceNow, a lot of those other tools in the tool chain, some of those things that you might be interested in that certainly apply in the area of microservices, containerization, serverless, but not a focus area today. And so we have an opportunity or an option to go ahead and do these builds and deploys straight from this project. So we could say, okay, we're in the Jet front end, or in the Java backend or the Oracle database, and we could perform a build at a project level, okay? Or we could perform a deploy at a project level. But what we're going to do is we're going to talk about how this can be done with releases and pipelines, and then specifically how we can go ahead and kick off a snapshot of a release that I'll talk about in a little more detail here in a few minutes. And so what I've done here is I'm up here pretending to be Eugene. I can't claim to be that deep technically, but I can edit this file and simply tell us to go. Because in essence what we're doing here is we're just making a simple change that's going to allow us to commit this into Git and ultimately drive the CI process. So we just did that commit. Go back over to Flex Deploy, and that we'll come back over and look at the dashboard in a bit. But what that's doing in the background is Flex Deploy is off. It's going to know that that commit took place, and it's going to kick off the build process. So when that happens and the build is actually executing, let's go ahead and take a look at a few other things associated with releases and pipelines. Going over to the release page, and on this release page, let's go ahead and take a look at this thing called containers, microservices, and serverless. And we'll open that guy up. And what you'll see is a release is basically a definition of one or more Flex Deploy projects that is going to make up the content of the release that you will then create snapshots of and move that over or execute that over a pipeline. All right. So in our particular case, we're keeping this fairly simple. It could be these three, or it could be these three plus tens or hundreds of other changes, whether they're using a microservices-based architecture and containerization, or it might be something like eBusiness Suite using more traditional build deploy technologies. In our case, for this demonstration, keeping it simple, we just went with the three projects that we've already talked about for the microservice. What we've done here, in addition to the name and description, is we've put we've configured the pipeline. So this pipeline that I'll show you, the simple pipeline, is really the process. It really describes what's going to take place and how you're going to manage the changes across your environments. So what we have here is, we saw this screenshot a little earlier, and in essence what it is it's three stages: development, QA, and production, mapping to the Flexagon Data Center, to Amazon, and to Oracle Kubernetes, and running that. Okay, and so basically what we do is we create these pipelines to be whatever we want, and they're reusable pipelines similar to what the workflow is, and then we put gates and steps in them as needed. You can have 0 or more gates, and a gate is basically anything from an approval to a schedule to maybe an automated test, anything that you might want to satisfy before allowing the execution of the steps for the actual deployment related activities themselves. And so in a nutshell, what we have is a deploy all. So those three projects will be deployed when the snapshot comes across the development. We've got a couple gates, both to check some test results and an approval in the QA environment. And then if those are satisfied, then we will execute the automated deployment. We will execute the functional regression test that's set up for this, and we will inject a manual test that's going to, in essence, that's going to allow us to insert human activity, right, manual activity where needed, since although we're certainly looking to continuous and the ability to, I will say, automate the entire process, but that's not the reality in some cases, maybe in many cases, with the maturity of where most enterprises are, so you can model that manual activity and do other things like notifications and such. So basically you create the pipeline as we have here, and now we can associate that with the release. All right, so we'll go back to the release here, and we have some options. We have an option to go ahead and create a snapshot of that release. So from this screen, and be able to say, hey, we've got some fixes, and that we want to go ahead and do a build of all of these, all the three projects, and we can kick that off or put some enhancements in there to create a brand new snapshot from this screen, because you might want to pick and choose either new or existing versions of these projects. But in this case, we said we're going to go ahead and create net new for whatever reason. Maybe we knew there was something in there, and so we're going to go ahead and create that, that snapshot. So we kick that guy off. If we come over to the dashboard, we will see that, yes, those are running at the moment. We've got the JET front end, the back end, and the Oracle database off and running. And so what these are doing are executing the corresponding build operations, right? Those build workflows that we configured to each of the projects. And then when they complete, those build images, the information that we've already talked about, that will be packaged up and then saved away in both the FlexDeploy artifact, as well as that as part of the build, the Docker image will be pushed up to Docker Hub, and then the reference to that will be saved as part of the build artifact. Okay, so while those complete, let's just go ahead back to the projects and let's drill into, well, first of all, let me just acknowledge the fact that as part of what we were just doing, it looked like we had a failure, right? And so what we could do is we could drill into that. And it looks like there was an endpoint failure. And so we could go in here, we could drill into the logs associated with that, and basically be able to troubleshoot that problem much more effectively because we've gathered up all the logs. But in lieu of time, let's just take a look at one of the latest builds that completed successfully, and we can go ahead and drill into that. And this should look familiar to you, right? So here we've done the export of the source. We've from Git, we performed that the OJet build, built the actual image and pushed that to the Docker Hub, okay, and then prepared that deployment profile. So all of that was done. It's basically the execution details associated with that. It created some artifacts that are going to be used as part of the deployment and save those away. And then there's other information that you have here that can be used as you see fit, if you will, for both triage, troubleshooting, as well as many customers like to use that depending on the level of detail they need for auditability. So a lot of that type of information. So in essence, what we've done here is we've kicked off that snapshot for the entire or all three of those microservices. It's completed 2 of them. It looks like the last time this guy was built, it took about 3 minutes. So in essence, what we have is it's wrapping up the build, and when that build completes, then that means that we will have what's required for build artifacts to be able to create the snapshot of that release and start executing that against the pipeline, right? So here we are, and as a matter of fact, this guy was started a bit ago here, but let's just use this as an example. So what we have is we've got snapshots over on the left-hand side, and in essence, what we've done is each time a snapshot comes through, it's going to start to execute the pipeline. You'll go here to development. No gates there, so it's going to execute the deployments. Oh, it looks like we just had our latest and greatest kicked off, but it's going to follow through that pipeline until ultimately we push something into production. So in this case, we're showing where it's not an exact realistic scenario, but in general what you'll have is a release that you'll have many snapshots, and you will only make it through either development or QA, and you'll iterate on that very rapidly, repeatedly, and in an automated fashion as your process is described in the pipeline. And then eventually, it'll make it all the way through to production. So that might be daily release cycles, weekly release, quarterly, whatever makes sense in your enterprise. And so if we come up here and we look at the latest snapshot, it looks like that guy has already made it through and is waiting on the QA approval. It's passed its tests. So I'm just going to go ahead and say, hey, we're good to go. Good to go. We want to move that into the QA environment. So I was the QA manager, or playing the role of the QA manager in that case, and now we are moving along, and we've satisfied both of those gates. So FlexDeploy will now say, okay, let's deploy all of the projects. We can drill into that. I'll drill down one step further, and these deployments into the Kubernetes clusters are very, very fast, right? Now, we could continue to drill down into that, but we won't. But just so you know that traceability, drillability, if you will, into the details. I'll come back up to the dashboard, and you'll notice that we're waiting on this manual task, right? So if I come up here to our tasks, go look at human tasks, I'm sure will show up here. So yeah, here we are. I'm looking at everything, and in the QA environment, we've got this human task. I could claim that, or I could complete it. depending on some of the advanced features of how we do human task management within Flex Deploy. But I'll just go ahead and say let's go ahead and complete that task and continue on with our release. So I'm bouncing around a little bit, but hopefully you get the point there. So now what's happened is if we go back up to the release dashboard, basically due to the automation and the automation of those projects using those workflows, we went ahead and deployed the same build artifacts for those three projects, right? The larger 3-component microservice, deployed all of those automatically to the Kubernetes cluster running at Flexagon. We passed the gates in QA and then subsequently deployed all of those projects into the Kubernetes engine running on Amazon. And now we're sitting up waiting for our gates to be satisfied. And if and when they are satisfied here in production, then it would go ahead and follow that same process with the same build artifacts, if you will, and deploy that into the Oracle Kubernetes engine. So in part, hopefully there's a few things that you're seeing here. One is the automation aspect of this. So you can automate the processes. You can make them very repeatable. You can put structure and governance around them, and you can leverage this broader set of releases and pipelines to be able to, using microservices-based architecture, be able to deploy, leverage the build and deploy for both Docker and Kubernetes and the out-of-box capability that you get there with Flex Deploy. Okay, so with that said, let's head back to the next few slides here. And really, in the abstract we sent out, there's a lot of things we can cover here in and around microservices, in and around containers, and then cloud native and things like serverless and functions. And so Eugene's going to wrap up the presentation and give you a little bit of perspective of serverless. And I would say just watch this space as it relates to additional webinars and such, because we continue to invest heavily in supporting this aspect of cloud capabilities.
Okay, so let's look again at our workflows to build and deploy our application. Every single step in a workflow is executed on an endpoint or some server capable of doing this job. For example, in order to build an Oracle Jet application, the endpoint where the step is being executed should have NPM and Oracle Jet command line interface installed. In order to deploy a container to a Kubernetes cluster, an endpoint where the step is being executed should have kubectl installed, and what is more important, it should be pre-configured with a target Kubernetes environment, and sometimes it can be painful. So what it means? It means that we are dependent on our infrastructure. We need to configure it, we need to think of it, and we need to keep in mind that and only that server can build Oracle Jet applications, and that server can deploy to Kubernetes clusters. So do you think it would be possible to hide those dependencies into Docker containers? What I mean, we could create a Docker container and put inside it everything it needs to build an Oracle Jet application, another container to build a Java backend application, and a container with pre-configured kubectl to deploy to Kubernetes clusters, and a container with SOAP UI installed to perform automated testing. Those containers can run actually everywhere on any machine having Docker engine installed, so we can even run them on a Kubernetes cluster. That's really cool. If we look closer at those steps like build, test, and deploy, we'll see that actually they're totally stateless. They serve one goal, they accept parameters, and they return the result. In other words, they work as functions. Another consideration is that we still need to think where these steps containers are going to run on. And in order to execute them, a consumer of those steps should use some tool, either Docker or kubectl. And here's where serverless comes to the scene. So serverless is a paradigm that brings the idea that a unit of work consumes computing resources only when it is used. So once a unit of work is being called, the platform implementing serverless rises it up from ashes and kills once the job is done. A unit of work in serverless is considered as a function, meaning that it is totally stateless, serves one goal, and accepts arguments or parameters, and it returns the result. Those functions can be arranged in a flow, and serverless platform takes care of the state of the flow execution, including error handling and transaction management. As a result, serverless brings a number of benefits. So sometimes we may see that serverless is considered as a code-centric paradigm. It means that we don't think of infrastructure anymore, or we just have a platform capable of invoking our functions, and we don't care where exactly those functions are going to be executed. So we are totally focused on our code, on implementing our functions. Furthermore, normally, a serverless platform takes care of scalability. It rises up as many instances of units of work, as many functions as it is needed according to the current load. A huge benefit of serverless is about billing. Since we consume computing resources only when we really need them, we don't buy air, so we don't pay for the idle time. And another thing is that we utilize our hardware way more effectively. We don't slice our servers into a number of virtual machines for different types of work. We can run a great number of pieces of work on the same virtual machine. Actually, there are a number of available serverless platforms on the market today. Some of them are commercial, some of them are open source, and it's definitely on our roadmap to integrate FlexDeploy with major players on the market, focusing on container-oriented platforms like Oracle Functions, OpenFaaS, Azure Functions, and others.
Right. Yeah, I think that's a good intro. Not having a lot of time to talk about this, it's really an exciting space. As an automation company, Flexagon, and certainly the software side, there's just so much upside potential related to serverless. So, with that said, that wraps up the presentation and the demonstration. We've got some resources here that you'll get in a follow-up email with links to this various information, things that we've done at Flexagon, things that Eugene does, and lots of other information that you can have of a good breadth and depth of detail on some of these topics. Okay, so let's head to Q&A. Looks like, let's take the first question here. First question is related to deployment sequencing. So let me go back here. So the question is there a way to sequence the deployments? And the short answer is there are multiple ways to be able to do that. In our particular case, it's pretty simple, but the real world says that there's sequencing and dependency management, all of those things that are needed. And so I'll bring up another example just to show you one way to possibly sequence. And so this is a different pipeline, but if you look at here, the steps here, it is breaking down the different types of deployments in different groups. So in this particular pipeline, that release has anywhere from middleware changes, some ERP changes, like I believe this is for eBiz. Here's some Java, SaaS, I believe this might be Salesforce. These microservices that we talked about, whatever they are, so that you can either serialize and sequence, you can run things in parallel, you can do whatever it takes to be able to orchestrate the work in a way that deals with dependency and sequence management, as well as deal with the reality of trying to push as much throughput through the overall pipe as you can. Okay, so that's just one example. We'll save that for another time in terms of there's other ways you can handle that sequencing within FlexDeploy. Okay, let's see. There's other questions coming up here. Maybe this one's for Eugene. Okay, why is Kubernetes more preferable than Swarm? So I guess that's then Docker Swarm for those of you who aren't familiar with one of the, I'll call it competing, orchestration technologies out there. Eugene?
Well, yeah, so this is about Docker Swarm, and there are plenty of pros and cons in both technologies, but I would highlight a couple of benefits of Kubernetes. Well, Kubernetes gives you more granular approach to decompose your application into pieces and it combines those pieces by the means of pods and replica sets. Another thing is Kubernetes has a huge community supporting and developing the solution, and it is also backed up by Cloud Native Computing Foundation organization.
Yeah. You know, I think so. And there's actually another question in here that I will relate this to. The question is what cloud providers have Kubernetes engines? And we talked about a number of them, so Amazon and Google, Azure, Oracle, you know, the list goes on. But I think at the end of the day, when you ask about the preferabilities, if it's, you know, not talking technical details, but because of how pervasive it is, really the latter point, the energy behind Kubernetes is incredible, right? And so the reality is the cloud providers, you know, are all going to have offerings in this space. If they don't already, they will. But we certainly see a lot of activity across all the major guys. All right, let's see. Well, how about this guy? Another one maybe for Eugene. So we want to use Kubernetes on-prem for development and testing. Can you recommend a specific Kubernetes version for that? Eugene?
Yeah, sure. So basically you can use what we use here in Flexagon. There's a special tool for that purpose, which is called Minikube. Minikube is a special edition of Kubernetes cluster. It runs a single node cluster inside a virtual machine on your laptop or on a standalone machine in your network. It was specially designed for users looking to try out Kubernetes for development on a daily basis.
Right. Yeah, that sounds good. Well, I don't see any other questions coming through here. So let's call this a wrap. We want to thank you for attending. Hopefully you have some additional insight into microservices, containers, how they can be deployed across multiple Kubernetes clusters running in different cloud environments, and then a little bit of understanding of serverless. Certainly an exciting time, and we hope you enjoyed this. Look forward to seeing the follow-up email with pointers to some of those resources. I want to thank my colleague Eugene for joining me here on the webinar today, and please join us in future webinars as well. Thank you. Goodbye.